Welcome to Summarize Science. On August 23, 2023, India made history by becoming the fourth country to soft land on the moon with its Chandrayaan-3 mission. This paper details the incredible engineering challenge behind designing its landing trajectory. The core problem is a classic trade-off. You want to use the absolute minimum amount of fuel, but you also need a plan that is robust enough to handle unexpected errors. The entire landing, called the powered descent, is broken down into distinct phases, like rough braking and fine braking. Think of it like a car carefully navigating a difficult parking spot. Using a powerful calculation method, the engineers first designed the theoretically perfect, most fuel-efficient path from an altitude of 30 kilometers all the way down to the surface. But a perfect plan on paper is one thing, reality is another. The lander's onboard guidance system is powerful, but it's not perfect and can't follow the ideal path with 100% accuracy. So, the designers had to answer a critical question. What happens if the lander is slightly off course or its engine thrust is a little different than expected? To answer this, they moved to a second, crucial stage, waypoint refinement. They simulated thousands of slightly different scenarios to map out a safe zone, the collection of all starting points from which the lander's guidance system could still successfully land. They found that the most fuel-efficient path was actually right on the edge of the safe zone, which is a very risky place to be. This chart shows that risky, fuel-optimal point labeled O. To increase the mission's chance of success, the team decided to shift their target waypoint to point N, moving it deeper inside the safe area. This crucial decision wasn't free. As this second graph shows, buying this extra safety margin cost an additional 25 kilograms of propellant. It was essentially like using fuel to buy mission insurance. And here is the final result of that two-step process. This diagram shows the complete flight path that Chandrayaan-3 was programmed to follow, incorporating all the phases from high-altitude braking to the final, gentle touchdown. This is the blueprint for a successful lunar landing. So to recap, the key insight from this work is that designing a complex mission like this requires a two-stage approach. The first stage is to use optimization to find the mathematically perfect, most fuel-efficient path. The second, and perhaps more important stage, is to refine that path to make it robust. By understanding the limitations of the real onboard systems, engineers can make an informed decision to trade a little bit of fuel for a much higher probability of success. This clever balance of pure optimization and practical, robust engineering is a major reason why the Chandrayaan-3 mission was such a stunning success. This design philosophy will be vital for future autonomous missions, making exploration of the Moon, Mars, and beyond safer and more reliable. Thanks for watching Summarize Science.